Hey gang, it's Dynamic Math here. I want you to check the applet out below this YouTube video. In fact, I don't want you to just watch this video just for the sake of watching it, because learning mathematics should never be passive. You don't learn by watching, right? For the same reason you don't learn how to become a better juggler by just watching somebody else juggle. And you can't learn to become a better swimmer by watching Michael Phelps in the pool. No, you actually have to jump in the water and swim yourself. So for every video in this series that you actually watch, there is an applet below that I want you to actually interact with as you're watching the video. So please, I beg you, pause this video as much as you need in order to make sure you fully understand what's going on here. So check out the applet below. It's the same applet that I have up here. Right, you have a bird's eye view of a circular amphitheater here. Okay, there is a blue stage area which you could change the size of if you just mess around with the endpoints there of that stage. Okay, and you could also make the radius of the circle bigger by moving the little white point there on the circle. Okay, center of the circle is gray right there, and there are 3 seats in this theater supposedly. Right, you're allowed to sit anywhere. Watch my cursor right here. Anywhere on this black dashed circle. Okay, you are allowed to sit in one of those 3 pink seats right there. You got one on the left. In fact, you can move it a little bit if you want. You got one right in the center there, sort of, kind of right in the middle, I guess. And there's one right here on the right. So here's my question to you. Don't slide the slider yet, but just hear me out. Let me ask. Where do you think the best viewing angle of the stage is? Is it on the left, in the center, or on the right? Think about it. What say you? Well, most students I give this problem to will always tell me, well, it's definitely the center angle. And, well, let's put your hypothesis to the test here. Take that slide me slider and slide it slowly. Watch here. We're translating the angle, so we're not changing the size of it. Remember, translation preserves angle measure, and then a rotation preserves angle measure as well. And wait a minute. What does that tell you about these 3 angles here? They're all what? If you said congruent or equal, you're absolutely right. Well, let's hit the reset button. Does that work every single time? Why don't you try making the stage a little bit bigger? And try moving those pink points somewhere else. Let's put this one in the center, right? And let's drag this one that was on the left. Let's bring it all the way over to the right. And let's slide that slider again. If the stage is bigger and there's my viewing angle, everybody on that circle, as long as you're sitting on that dashed black circle right there, you all have the same viewing angle of the stage. You surprised? Most students have a hard time believing that, but it's actually true. Now, these 3 pink angles are actually called inscribed angles, and you're going to learn a lot more about inscribed angles in the next upcoming activities here on GeoGebra and with the applets that accompany the videos you see here. So I would recommend going to this link next and have fun. Thanks for watching.